Now, pandemic is not something new. Okay, we have known throughout history that there has been pandemics. Okay, and almost every time after the pandemic, society change. I think what is very uh, uh, interesting or what is very obvious was during the Dark Ages when there was this Black Death, which went through the whole of Europe and killed almost half to three quarter of the population. And I believe that's the time when modern Europe arise from the ashes. Do we have pandemic in our time? Yes. No, I I can I mean the last major pandemic was the 1918 to 1920 influenza, which killed about 20 million people. But closer to our time, I wonder how many of you remember SARS. Okay, SARS was worldwide in 2002 to 2004. Okay, and Singapore was hit very badly. Okay, my wife worked in Singapore General Hospital. So at one time she was afraid to come home because of the SARS. Okay, but for some strange reason, I mean, I was with the General Hospital at the time, and we were waiting and watching for the SARS to appear in Malaysia. For some strange reason, it never crossed the causeway. Maybe he didn't have a passport or something. Okay, so there were no cases in Malaysia of SARS. Nobody believes us, even WHO doesn't believe us, but there were no actual cases. Then the SARS died off. After that, in 2009 was the avian flu, H1N1. I'm sure you have still remember that. Then 2014 was the Ebola. We don't hear about it much because it was in Africa. And then in 2016, the MERS, the Middle East respiratory distress. And again, we were on high alert. My hospital was on high alert because a lot of our patients goes for Umrah and the Hajj. Okay, and we were afraid that they will bring back. But again, it never touched our shore. But we have been preparing for a pandemic ever since SARS. Okay, we were expecting and preparing for a pandemic. That's why you see that when the pandemic hit us, we were not actually unprepared. We were actually preparing a vaccine since the SARS days. We actually have a vaccine for Ebola. And the vaccine for Ebola has been around for 2 years. Again, it wasn't given much attention because Ebola doesn't make much money. Now, if we look at our situation today, okay, this is the latest information I have. There are about 109 million people, 109.2 million people infected, confirmed cases of COVID, and 2.4 million people died from it. So it is a major crisis. Okay, it's a crisis that we hope we will live through only once in a lifetime. Okay, and yesterday's figure says in Malaysia, yesterday was 2,998 cases, which is very high. But what is scary was yesterday we went over the 1,000 death mark. Okay, so 1,005 people died. So you see that it's very spread in various states. What is we actually watch more concern is the number of cases in ICU. That gives us a true indication on how serious the condition is and what we need to do. Well, we lived through 1 year of SARS, and I believe the Ministry of Health has done a good job. Okay, we in the first wave, actually in November, December, the doctors are aware that there's something happening in China. Okay, only thing we do not have much news at that time. Okay, then it, when the first wave hit us in January, we went into the MCO, which I think did a good job in the sense that it gave us time to prepare the healthcare system, okay, to prepare for the isolation, SARS dedicated hospital, and all that. So we would actually making progress. Then come the second wave, okay, and then the third wave, which you know certain things happen, and then everything goes haywire. So we are now in the reaching a critical point, okay, critical point in our uh, pandemic in Malaysia. And we have learned actually in the last year, we have actually learned a lot of new things. Okay, we are learning from treating patients and all that. And we learned that our mortality rate is about 0.4%. Okay. Or since yesterday was 0.3 something, which means that 4% of every 1,000 will die. 1,000 infected. Okay. It may not seem very high, but you know, those who have people who are family members who died, it is significant. And it's more in male. And you find that the factor that affects the people the most are the age. Okay. Those in the 60 to 69 group are at the high risk. This is Malaysian data, no? Okay. And those who have comorbidity, that means high blood pressure, diabetes, and all that, are increased risk. So we know who are the high risk people, who are the people we should protect. Okay. Now, just to go back to the start of vaccination. Okay, we know that vaccination started in the 18th century. Okay. When this Dr. Edward Jenner noticed that milkmaids who are exposed to cowpox do not get chickenpox. So that was a good observation. He's a good observer. But what he did need next was that he grabbed the gardener's son, 8-year-old boy, and he scratched the arm and he put some cowpox past there. And then he next exposed the child to a person with smallpox. And the child survived, didn't get smallpox because he was infected with cowpox. And that is the start of the modern vaccination program or project. And now it's so as well established that all the young children go through what we call the extended vaccination program, okay, which protect them against 11 types of diseases. Okay, all the children are all vaccinated, and Malaysia is actually regarded as one of the countries with the best healthcare in the world because our mortality come down, and we almost vaccinated everybody. Now, the way Edward Jenner did it, in this time is acceptable. In the 18th century, today we will have grabbed him, okay, accused him of child abuse, accused him of experimentation on human being, accused him of manslaughter. So times have changed, even though the scientific method has not. And we keep that in mind as we talk about vaccine. Now, the other thing you have to keep in mind as we go along in this talk is that up to today, okay, 181 million shots have been given, or 181 million vaccine has been given. And they only started the vaccination in mid-December. So we're talking about 3 to 4 months experience in the largest vaccination program in the world. Okay, so we are talking about the vaccine going into the public. Already 180 million people have received the vaccine. Okay, so that is a very important fact that we should keep in mind as we go along. But first, what are the vaccines? Okay. Basically, we can divide the vaccines or the COVID-19 vaccine into four categories, four different groups. Okay, you find that the first is the inactivated or attenuated. So inactivated vaccine, okay, where's the weakened? Yeah. So this is very familiar to us. Okay, we use it BCG, MMR, chickenpox. All these are we took the original virus, we expose it. Okay, either we kill it or we expose it to different things and make it very weak, so that they are either inactivated or attenuated, means very weak. And then when we use it as a vaccine, the body reacts against this weakened virus and produce antibodies. So these are the so this is known technology, it's not new. Okay. Now the protein particles, protein-based vaccine. Here, what they do is to use particle part of the virus and then export and use it as a vaccine so that the body will react and produce antibodies against that virus. So again, it's not new technology. Okay. Now, the third one is the viral vector. That means what we do is that we use something that infect human cells, and then we put inside the something uh, the part of the genome of the virus. So in other words, we're using that as a vehicle to enter the body, enter the cells, and then they will produce antibodies. So we call the viral vector vaccine. So it means it's like putting the virus into a car and let the car go through the what, okay, and then this is the latest, the nucleic acid or the RNA, where we actually use the genome and what, okay, we are talking about technology. Since the year 2000, we have actually sequenced the genome. So now we exactly know how to do it, and since then we have CRISPR, which is a new technique of editing the genome. So that means it's like we can cut and paste and all that. It's like using the Microsoft Word like that. You can actually design your own genome. Okay, more about that as we go along. But I just want to that you're clear that this is the SARS-CoV-2 virus, the COVID virus. Okay, the COVID virus is actually so close to the SARS virus. That's why they call it SARS-CoV-2. It's a cousin of it. Okay, and this virus is a what we call the RNA virus, which is actually a very simple virus. Okay, it contains the RNA, which is a very short line of genomes. Okay, it's like a computer code, but it is protected by a lipid layer capsule. Okay, and then they have four major proteins. Okay, take note of the spike protein, because the spike protein is where all the vaccines are directed. Because if we can have antibodies against the spike protein, then the body can destroy the RNA virus. Okay, so here we have the common one that we are used to, the weakened virus or the inactivated virus. Okay, the virus is weakened, okay, or is killed by formaldehyde or heat, and then they are put in a vaccine and injected, and the macrophage, the T cells, the B cells, and plasma cells act against the weakened virus and produce antibodies. The antibodies actually goes to the spike protein. So this is familiar technology. Here we break apart the virus and we take the viral component, which is actually the spike protein. Remember the spike protein? We break it out and then we use the spike protein okay, and put into a medium, and then use it as a vaccine. So when the spike protein is in the blood, in the plasma, the T cells and macrophages will go against it and produce antibodies. So that is the protein base. So protein base is, again, familiar, nothing new. Now, the viral vector, okay, use also partially use new and partly old, because we use it as a for measles. Okay, what we do was that we use a virus like adenovirus or common cold virus that easily infect human beings but don't kill human beings. Like, and then we put part of the genome into the virus. Okay, or the use an virus that we, again, the part of the genome, and then this is made into a vaccine, and then it's injected. So the virus, the vector will infect the cells. While in the cells, okay, the RNA comes out, this part of the RNA, okay, and then it produces immune response. Okay. Now, you must note that of all the new vaccines, okay, we don't actually use the COVID, SARS-CoV-2 itself. We actually can make the genome already, so we don't have to use the virus itself. Okay, and of course the new one is the either DNA or the RNA. So again, we actually can make the RNA, the genome, okay, which is because we have the information. And that is one of the interesting thing about the vaccine, is that when the vaccine was actually, when the COVID epidemic started in early January, okay, the Chinese scientists has actually sequenced the RNA. And what is impressive and wonderful was that the Chinese scientists actually put it on the internet, the complete sequence of the RNA, so that within days, the whole world or the scientific community knows the exact genome of the RNA virus. That's why even in January itself, the couple who runs Bio Tech, okay, here's a research institute. Within 2 days, this couple came out with a vaccine for COVID in January 2020. Okay, that means last year we already have the vaccine, but they cannot produce it. So that's why they partner with Pfizer. That's why it's called Pfizer BioNTech. Okay, so now they are able to make the RNA, okay, and it's coated in a lipid nanoparticle. So the vaccine itself is actually nothing but the artificial computer code coated in a lipid layer that is injected into the body. Okay, it's injected into the cytoplasma of the cells, and then the genome started producing protein particles, which goes into the bloodstream and is attacked by the body's macrophages and produce antibodies. The DNA one is actually goes into the nucleus, but it's a RNA, it's not a DNA. So it cannot, and it is designed in such a way that it doesn't interact with the original DNA in the nucleus. So again, it produces RNA and produce a protein and produce one. So this is the new vaccine. This is the one that we are talking about.